All right, so now we're going to start working from in the other direction. So we're going to go from the perfect square trinomial, like this, to the square of a binomial squared. So let's take a moment and look at what the patterns that we noticed. So remember that this is B, and this is. So all these perfect square trinomials fall into the form of ax squared plus bx plus c, where c is the constant term, which just means that there's no variable. B is the coefficient of the x to the first power term, and a is the coefficient of the x squared term. Okay. And you'll notice a pattern here probably where in going from standard form to the square of a binomial, you'll notice that b is always two times this number, right? And c is always this number squared every single time as you look back over the ones you just practiced. Okay? Now, in order to factor, we can probably just skip from here to here, but we're going to go ahead and talk about putting some steps in between. So I'm going to work through an example, and then I'm going to use this as a pathway back there once we get there. So if I have x squared plus 22x plus 121, then you might begin to notice, well, half of this number here is going to be this number that ends up right over here, 11 squared. Now, but you need to check and see if 121 is 11 squared. I can plug that into my calculator and that equals that. So then this actually checks out. But let's put some steps in between. Now you'll notice that every single time, right, these always combined to this, and that's why this is always twice this second number here. So if we put that back in there, 11x, and doing what I call split that middle term back up, then what we can actually do is use the beloved box, where we put the x squared here, the 11x here, this 11x here, and this one down here, the constant term c. Okay? Then we can start factoring and we say, well, what are my common factors along here? 11. What are my common factor here? 11. What times 11 makes 11x? An x and an x. And you can see that my factors are x plus 11 times x plus 11, just like we did here. And so then we could rewrite this as x plus 11 times x plus 11, which then equals x plus 11 squared. Now I don't need you to do all these steps in between. I just want to show how we get from this perfect square trinomial to its factored form written as a square of a binomial. Now, and this is a square of a binomial. Now you might be asking, what the heck is a binomial and a trinomial? Well, the key is right here. Tri means three, nomial means terms. And this is binomial, two terms. Terms are things that are separated by addition and subtraction. So binomial has two terms. A trinomial has 1, 2, 3 terms. So that's factoring a perfect square trinomial. And you can use those patterns. So for example, if you get this one, x squared minus 8x plus 16, then you might say, well, half of 8 is 4. So my x's match. Half of 8 is 4, and 4 squared is 16, so there's going to be a 4 right there. And then this sign is always going to go right there. And that is that. I want you to go on the sheet and practice rewriting all of these perfect square trinomials as square of a binomial.